So we're here for an hour and a half to talk about machine learning. I'll spend about 20 minutes at the start talking about machine learning, what that is, the role that's going to play in industry over the next few years. And we have a couple of speakers who will present about the couple of applications they have. Michael Hackney, who's a VP of product at Railcom, and then Rob Miller from Flowserve as well will present a couple of applications. And then finally, we'll have a QA panel to wrap that up. So just a quick plug for ARC then before we get started. A lot of folks on the industrial IoT team at ARC blog at industrial-iot.com on a regular basis. We post there basically once a day, pretty much, 5 days a week. I myself write about analytics and cloud and anything else I find particularly irritating, to be perfectly honest. Other people like Greg Gorbach weigh in there as well. So it's a great place to come and learn about what's happening and get updates and our fresh insights. We often publish there before we put stuff down on paper. So it's a great place to stay abreast. And we have a number of guest bloggers coming in there too. So check that out. If you don't want to go there every day, you can subscribe for a newsletter, which will get pushed to you once a week as well. So it is, I hope you're aware of this, it is actually an audience participation event here. So quick show of hands then. Who believes they've used a machine learning application? Okay, there's a few, but that's a little disappointing, to be honest. As John Bon Jovi once, I'll try that again. I'll stay back here. As John Bon Jovi once said, I want to see all your hands in the air. So, who uses Netflix? Okay, that's about half the audience. Netflix is a machine learning application which happens to stream video. Still need your hands in the air, please, Netflix users. It won't be long. Thank you, thank you. Who talks to that phone? Who uses voice recognition on their phone? Okay, that's a lot more people. We've got probably 75% right now. Final one, this is the killer. Who shops on Amazon? Amazon is a machine learning application. Thank you. You can all put your hands down. I think John Bon Jovi would be proud of us right now. Amazon basically uses machine learning in order to recommend other products to you. Okay, so again, it's a core part of what Amazon does. So let's talk about where machine learning fits into what we talk about as an analytics taxonomy. We talk about 4 buckets of analytics things at ARC. I'll talk about 3 of them right now. We talk about describe, which is basically looking at static reports, static dashboards. There's an example there. We all have them. It's our phone bill. Utility bill is a static report. You get it through the mail in paper or online. You can't dig into that in any way. It just shows you basic information. Alongside that, we move into what we call the Discover bucket, which is a much more interactive way of looking at data. In the middle of those, the intersection of those two would be interactive dashboards. So something like this, dashboard from a wind farm. You can see the 3rd row down, there's a little red light on that row, tells me something's not quite right with that wind turbine. I can click on that. I can get down into more detailed information about that wind turbine. So through using interactive analytics, I'm starting to be able to see cause and effect, starting to be able to get to root cause of problems within my equipment. And then right out on the extreme of that axis, we'd look at tools like Spotfire or Tableau, which are providing a very full-on, interactive, immersive experience of how you look at and work with data. So across the spectrum there, then we go from using data in a very static way, very static representation and passive way of consuming data, through to a much more dynamic and interactive way of looking at data. The 3rd bucket we talk about is predictive analytics, which, if I summed it up in about 6 words, is using statistics with large, complex data sets. So very much a big data play, understanding patterns in data. And then machine learning is really a subset of that. Machine learning I would define as automated, embedded, self-modifying predictive analytics. So how does that play out in the Netflix world, right? Netflix, remember, is a machine learning application. These recommendations down the bottom of my Netflix homepage here, they're all put there by and large by machine learning. Now myself, I watch a lot of crime thrillers, detective thrillers, that kind of thing, Nordic noir, seen The Bridge and The Killing in the original Swedish and Danish versions, for example. So Netflix put some recommendations in there. The Fall is a crime thriller based in Northern Ireland with Gillian Anderson pulling off quite a pretty passable English middle-class accent, probably better than mine at this point. And Jordis, I'm not sure if I said that right, is basically about a Swedish school teacher. So because I've watched Scandinavian crime thrillers, I get both of those things populated there. The Fall, I might go back and watch that. The Swedish school teacher thing, not so much. But the algorithm will learn from that and it will adapt to that. So if we go back to what I said about it being automated, embedded, and self-modifying, machine learning is an embedded part of the process. There's no way I can get around that. If I use Netflix, I have to use it. It's self-modifying. It will take the things I click on and the things I don't click on, and it will change the algorithm to provide me with more appropriate recommendations for my taste. And that just happens automatically. I don't have to actually do anything to make that happen. So it's a very, very seamless experience. So machine learning, then, we could also say, it's really for problems that you can't code. Okay, if you can't define the rules or the logic behind an application, if you can't figure out how to program it, then machine learning is a good candidate for that kind of problem. So for example, machine learning is for recognizing cats. So back in 2012, a bunch of data scientists at Google used 16,000 processors to build a neural network, which is a machine learning algorithm. They used 16,000 processors to build that algorithm. They threw 10 million images past the algorithm, and it learned how to identify cats. Nobody told it what a cat was. Nobody told it what an image of a cat looked like. It just figured it out all by itself, as if by magic. And the way they did that, they used a learning technique called unsupervised learning, which is basically where the algorithm looks at the data, classifies things, and categorizes them. So you define the algorithm, you throw it 10 million images, and Google, if you like, the algorithm sorts those out for you. And when you go back and look at it later, you say, oh, look, all the cats are in one bucket. So Google learned to recognize, the algorithm learned to recognize what a cat was. Now, if you show it other images of cats, it will recognize them most likely. So how do you code that, right? If you think about the kind of problem that is, how would you write software to recognize cats from 10 million images? Very, very difficult to do, and so that's the kind of role that machine learning can play for you. An alternative approach to the unsupervised learning that Google used would be supervised learning. And in practice, a lot of applications use both aspects. Supervised learning is like teaching a 2-year-old. Okay, I'd have to sit down with Johnny here and say, here's a cat. This one isn't a cat. This is a cat. That's a cat. That's not a cat. That's not a cat either. And so that's how a 2-year-old learns, through supervised learning. You're showing those images all the time, and they pick up from that. So 2 different approaches, often combined in practice, like I said. So let's talk about why machine learning is hot. Machine learning isn't new, right? The basic algorithms for it were defined back in the 1970s, 1980s. The algorithms, the basic algorithms are all public knowledge. They're in the public domain. There's been some refinements and tweaks to those over the years. But the algorithms have been known for a long time. But if you think about it, back in 1980, who had 10 million images of cats or anything else, right? Who had that data? Might have been 1 or 2 government agencies who probably weren't very open to sharing that data, but nobody had that much data. We now live in an era of plentiful data. Netflix has 65 million subscribers, all providing data for their algorithms to get better. Over 400,000 tweets a minute. And this last stat here blows my mind. That stat is actually 2 years old. allegedly 1 billion photographs are uploaded to Facebook every 3 days, which is just a staggering number. Facebook has 300 petabytes of all your data. Phenomenal amount of data. A petabyte, if you had a petabyte of music, it would take you 2,000 years to listen to that. So phenomenal amount of data that now exists. That's obviously in the consumer space, but we're starting to see that in the industrial world as well. This GE engine on a Boeing 787 Dreamliner generates 5,000 data points a second. So when it flies across the Atlantic, you're getting 250 million data points off both of those engines. Somehow, you're going to have to look for patterns in that data to maybe improve your maintenance schedule, to predict when things are going to fail, to predict how you could run the engines more economically. Somehow, you have to make sense of all that data. And machine learning is going to be one of the ways that we do that. The other reason why machine learning is hot is the barriers to entry are lower than they've ever been. Gordon Moore is still more or less right. We're still getting more or less twice the performance out of CPUs every couple of years. So the underlying technology is still improving. We're now also starting to use, data scientists and machine learning people use GPUs, graphics processing units, rather than CPUs. So the CPU that you all have in your laptop, for example, typically has 4 cores, maybe 8 cores in it, 4 separate processors. And they're designed to run a very wide range of workloads pretty well. The GPU, graphics processing unit, on the other hand, only runs a small number of tasks, but it runs them extremely well. And if you have an avid gamer in your family, you already own at least one high-end GPU. They're in your Xbox, they're in your PlayStation 4. So what they've been used for historically is updating pixels on a screen very, very rapidly in sync. High-end card will have 2,000 cores plus on a single piece of silicon, for example, and they're all coupled to work in parallel as well. So data scientists are now starting to use GPUs because they see that they more accurately mimic the human brain in some ways, right? The gray stuff between our ears is basically billions and billions and billions of very simple processes that are very richly connected. And they map better to a GPU than a CPU. And the third reason that barriers to entry are low is because of open source and cloud computing. So all these screenshots I threw up here, just a handful, literally a handful of the companies who are active in machine learning right now. Open source, you can go there, you can download the software, you can get started for free. Very easy for people to do that. Similarly, cloud-hosted solutions from Amazon, IBM, Google, Microsoft, and a bunch of other startups. Go to their website, sign up for registration, you can start building machine learning models for free. Okay, very, very easy to get started. You can go there, you can play with it for a couple of days. If you don't like what happens, take it away, try another one. Incredibly low barriers to entry to start building machine learning applications. The space is, in fact, so hot right now that last time I looked, there were 748 startups active in machine learning. Now, a lot of those are in the consumer space, but some are in the industrial space as well, so incredibly dynamic time.